Okay, so you have the topology with multiple network. The first requirement is, the first thing you need to determine is how many networks do you need? How many different subnet ID do you need? So you look at the topology and then you read the requirement. So the requirement is here. So first of all, your original network ID is 192.168.0.0. So this is the ID, network ID that you have to subnet into multiple network. So the first subnet is the LAN A network. So if you look at the topology here, this is the LAN A network and it's connected to the router interface. That means it's a separate subnet. Every network that is connected to the router interface is a separate subnet. Okay, and this network need minimum of 50 hosts. So this network will be connected to 50 hosts. So you need at least 50 usable subnet IDs. Okay. The second subnet is LAN B. This is LAN B. Okay. And you need at least 40 host addresses. So when you're configuring your subnets, you have to consider the minimum host you need. So therefore you're gonna borrow the bits based on how many hosts are required in each subnet. So the second subnet requires 40 host addresses. You also need at least 2 additional unused subnets for future network expansion. So you don't know if your network is going to expand or not. Most probably it will. So whenever you coming up with your subnetting scheme, you create additional subnet in case your network grows. Because if you don't do that and your network grows, you have to reconfigure your whole network, which is a lot more work. So always anticipate future growth and create additional subnet. Okay. So let's start answering this question. Okay. The following question: how to create subnetting scheme that meets the stated network requirements. So these are the network requirements, and this is how we're gonna start subnetting. How many host addresses are needed? Okay. So how many host addresses are needed in the largest subnet? So the largest subnet, so between two, which one is the largest? Anybody? So between 50 and 40, the largest subnet is 50. How many? The answer to this question is 50. What is the minimum number of subnets required? Okay, so there are at least 4 subnets that are required. 2 subnets are already there, right? LAN A and LAN B. And then you need, the requirement is you need at least 2 additional subnets for the expansion. So the total number of subnets required are 4. The network that you're asked to subnet is 192.168.0.0. What is the 24 subnet mask in binary? So you have to convert the subnet mask into binary. So 192.168.0.0. So the first 3 octets are 1, 0, 1, 2, 3, 4, 5, 6, 7. No, sorry. So the network IDs are all ones. Okay, so that means 24 bits are used for the network ID, and uh, 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 and 8 bits are used for the host ID. Okay, so 192 is 111.178 dot 111.78 1 2 3 4 5 6 7 8, and the last would be all zeros 1 2 3 4 5 6 7 8. Okay, this is the easy part. Okay, the subnet mask is made up of two portions, the network portion and the host portion. This is presented in the binary by the ones and zeros in the subnet mask. In the network mask, what do the one represents? What do the one represents? Jean, what does all ones means in the subnet mask?
Is network.
Excellent. Benjamin. Benjamin, are you there? Okay, so the all ones means network. In the network mask, what do the zero means? Host. All zero means that this octet is belong to the host. Okay. To subnet a network, bits from the host portion of the original network mask are changed into subnet bits. The number of subnet bits defines the number of subnets. Okay. So whatever the bits that you borrow, that will become part of your network ID or the subnet ID. Okay. So remember, the number of host bits defines the number of hosts per subnet. Okay. So how many host bits you took from the host portion? So if it's 1, your prefix would be 25. Okay, so the dotted decimal subnet mask is equivalent to actually is 255.255.255.128. How did we come up with 128? Okay, by converting the binary to the decimal. You can use Windows calculator to do that. So let's see. So I'm gonna start Windows calculator. Okay, you use, let's see, so the binary bits are, so you see these are the binary bits. So if we do 1 2 3 4 6 7 8, so you see the decimal portion is 128. So that's how you come up with the subnet mask. You take so you borrow the bits from the host portion and then convert into decimal. You can use the Windows calculator to do that. Okay, so this is how you come up with 128. Dotted decimal subnet mask equivalent to 2552. So only the last octet change. Now, number of subnets and number of hosts. So so if you borrow 1 bits, what are the total number of network you will have, and what are the total number of hosts in each network? Okay. So number of total network are 4 subnets. Okay. And 64 hosts. How we come up with this? By using the power. Okay, the 2 to the power of 2 is 64. 64. No, 2 subnets and 128 hosts. So you have 2 subnets and 128 hosts. Okay. How we come up with this? So we borrow one from the network portion. Okay. We can use the window. You can use the Windows calculator here. Is it scientific? Yes. 2 to the power of 1 equals 2. Okay. And how many bits we have left for? No, sorry. We need 2 actually. So 2 to the power of 2 equals 4 networks. How many bits we have left here? If we took 2 bits, we have 6 bits left for the host portion. So 4 networks, 4 networks and 128 hosts. How we come up with 128 hosts? How many bits left for the host portion? 6. So 2 to the power of 6 equals 64 in each network. So the total number is 128. Okay. So dotted decimal subnet mask equivalent. This is how you come up with the subnet mask. Here, again, use the Windows calculator. This is 11000. So we go back to programmer. 1 1 1 2 3 4 5 6. Okay. So 1 2 3 4 5 6 7 8 224. Okay. And if you take more bits, it will be 248. 1 2 3 4 5 6 7 8. So you see it changes. The more bits you borrowed, the decimal value changes. That would be your subnet mask. Okay. So 4 bits, 324, 224, 192, 3 bits equivalent to 4 bits equivalent to 240. 3 bits equivalent to 224. 2 bits equivalent to 192. One, two, 3, 4, 5, 6-bit equivalent to 248. Number of subnets, number of hosts. If you borrow, if your subnet mask is 248, so 32 subnets and 8 hosts in each network. Okay, 34 subnets and 8 hosts in each network. Here, dotted decimal, number 6, 252, number of equivalent to 252. How do you get 252? 1, 2, 3, 4, 5, 6. So if you go to Windows calculator, this is how you get 252. 6. So you borrow 6. So you borrow 6 number to get 250 to get the subnet mask of 252. Okay. Number of subnets and number of hosts in this. So 64 subnets and 2 hosts per network. How did you get this 64 subnets? Here, again, calculator. 2 to the power of 6, 64. This is how you get 64 subnets, because these are the 6. We borrowed 6. And how many hosts in each network? How many bits we have left? 2. So 2 to the power of 2. Okay. 2 to the power of 2 equals 4. And remember, the usable IDs are the total number of ID minus 2, because the first ID belong to the network and last ID is the broadcast ID. So 4 minus 2 equals 2. Okay. 64 hosts and 64 subnets and 2 hosts. So considering your answers above, which subnet masks meet the required number of minimum host addresses? Okay. Number of subnet. So 26, 27, 29, 30 will give the required number of subnets. 26. All these, if you borrow 26, 27, 28, 29, 30, that will meet the requirement. 26, 27, 28, 29, and 30. What would be the subnet mask?
Sorry, sir, I don't understand where you're coming from. 26, 27, 28, 29.
These are the total. So here. So if we borrow, this is what we did. So if we borrow 2, 24 plus 2, 26. So it will give you the required number. Okay. 26, 24 plus 3, here you see we borrowed 3. 24 plus 3 is, John?
Yes.
27. So this is how you get 27. 24 plus 4,
Ten, okay.
28. 24 plus 4, 28. This is how we come up with 28, and so on. So you stop at the 28 bits because you need at least 2 bits for the host ID.
2 bit.
Okay. So which subnet mask require, considering your answer, which subnet meets the minimum requirement? Considering your answer above, which subnet mask meet the number of subnet required? You required at least 50 hosts in each network. Okay, how many bits will give you 50 hosts? Since look like Jean is the only one who's paying attention, so Jean, how many bits required to come up with 50 hosts?
I don't know exactly.
Okay, so let's start. So this is the formula I'm showing you. Okay, if we take 1 bit from the host portion, it gives me only 2 hosts. Is it good?
Mm, I know because you have
We
you
need
need
50,
to.
right?
Yeah.
Okay, so let's start one by one. If we borrow 1 host, no, not good enough. So we need to borrow more. If we borrow 2 bits, 2 to the power of 2,
4.
it gave us 4 bits, 4 hosts. No, not good enough. We need 50. Let's try to borrow 3. Let's see. Oh, only 8 hosts. Not good enough. So we need to borrow more.
So we're gonna take 4.
Let's see, borrow 4. Only 16. Not good enough. So we just keep going until we get our required number of hosts.
Uh,
So if we
the require
borrow
the require is, yeah, is it 64
50,
or
50, 50.
50? Okay.
If we borrow 5, we got 32. Not good enough. So voila, I guess if we borrow 6, it gives us 64 hosts. You will never get the exact number of hosts. It's either less or more. So
Okay.
what you do is you go with more, okay? Not
Mm,
less.
yeah.
Because even though you need only 50 hosts, but now you have 64, the rest of the IDs you can use later on because you will always probably add more hosts into your network. You will add more devices. So you have these addresses available if your network grows.
Okay.
So you have no choice but to borrow at least 64. Okay. So
Yeah.
considering you answer which subnet must meet the minimum number of subnet required. So now we have to come up with the subnet mask. So how many bits we borrowed here? 6,
Mm,
right? Here, look.
yeah, it's 6.
So
No,
what we're
no.
gonna do is we're gonna convert that into decimal. So we go to the scientific I think programmer calculator, and we're gonna convert that into decimal, and that's gonna give us our subnet mask. So
6.
1,
No,
2,
it's
3, 4, 5, 6, 7, 8. So that would be the subnet mask if you borrow 6 bit. Okay.
Okay.
So here we have, anyway, well, we can do another exercise once we, I don't know why it's not printing, why it's not typing here. 192.
You need to change the color of the font. It's always transparent.
Ah, yes, thanks. Where is the color of the font? Thank you, Yuri.
Anytime.
192.168.0.0. Prefix would be 26. And what would be the subnet mask? 255.255, 1.92. The next would be 192. Why is
You have to mark the whole document and then select the font of the text, because it's otherwise you will have to do that every time for every answer. Yeah, exactly like this.
and what I so 192.168.0.64, 192.168.0.64. Prefix would be 26 and 192.190. So the prefix and the subnet mask would be the same, okay, for every subnet. The last one would be 190. Sorry, next one 192.16. So these are your network IDs, okay? Anyway, I'm gonna do another lab with you guys later on, not now, but later on. All right, so once you have all your network IDs, okay, what you have to do is you have to assign in packet tracer these network IDs. So you have to choose one network. So where's the packet tracer? So this network could be 192.168.0.0, the original network, right? This network could be 192.168.0.64. So these are the two network. And then you assign the IP addresses to this network. So and then you have to have, then you have to assign the host IDs from that network, okay? So the first network is 192.168.0.0. 0, right? So what is the so what would be the first network ID from that network? 192.168.0.1. Okay. And the subnet mask is 192.168. No, sorry. 255.255. 255.192. 255.255.255.192. And the subnet mask would be the same in all these network. G0, G01, 192.168, 0 dot, it could be 192.168, 0.2, 192.16. No, sorry, because it's a different network. Okay, G0 is a different network. So what is the second network here? Second network is 64. Okay, what would be the first network ID in the 64 network? 192.168, 0.65. Okay, and then you assign two IP addresses to the switch from the same subnet. All right, so I'm gonna let you complete this and we'll see how you do it. Okay.